Welcome back to second part of presentation on turn-on methods of SCR. Myself Sanjit Kumar Singh, lecturer in Electronics and Telecommunication Department at Praveen Patil College of Diploma Engineering and Technology, Bhinder East. In the first presentation, we saw the concept of turn-on mechanism of SCR. Here in this presentation, we will look for the gate trigger circuits, that is R resistance triggering circuit and RC, that is resistance capacitance triggering circuit. So, gate trigger circuits where a signal voltage is applied across the gate cathode, and this signal can be obtained from DC source or pulse gate triggering or AC gate triggering. So, in DC voltage of proper magnitude and correct polarity is applied between gate and cathode, so that junction J3 is forward biased. There are drawbacks of this method, that is no isolation between power circuit and control circuit. Power circuit consists of the SCRs or the thyristors, whereas control circuit, the firing circuit, is the control circuit for turning on the power device. Secondly, the continuous gate current flow makes more losses, and therefore it is a useless and waste. Pulse gate triggering method, it will make use of pulse transformer for providing the isolation between power circuit and control circuit. Its advantage is to reduce the gate loss taking place. AC gate triggering method is adopted for AC applications where isolation transformer is used, and for the positive half cycle the SCR turns on, and for negative half cycle the step down transformer is required, and that makes it costlier. Now we have the turn on methods of SCR by making use of R triggering or RC triggering or UJT relaxation oscillator or PUT relaxation oscillator. In this presentation, we will see the first two, R triggering and RC triggering, though it is practically not much in use. Before that, we will see what are the conditions that must be satisfied in order to use the gate signal for turning on SCR. First and foremost is to make SCR forward biased. For that, anode should be positively supplied with respect to cathode. Secondly, the gate pulse width must be more than the turn on time of an SCR. That will ensure that the latching current is reached, and even though gate signal has been removed, it remains in the on state. Thirdly, anode to cathode voltage must be more than the finger voltage. What is finger voltage is below which an SCR cannot be turned on with a gate signal. Magnitude of gate current must be greater than the minimum gating current required to turn on the SCR, but should be less than the maximum allowed gate current. Otherwise, it will damage the SCR or the power device. And sixth, the gate triggering must be synchronized with the AC supply. Moreover, if there are more than one SCRs, then the firing circuit has to turn on each SCR at proper sequence with a proper magnitude and polarity of the gating signal. So it should be periodic in nature, and sequence of firing must be as per the thyristorized power controller circuit used. For example, if a single phase semi converter is used where two SCRs are used, during positive half cycle one SCR is getting the triggering pulse, and during negative half cycle the second SCR will get the triggering pulse. Similarly, for a three phase full converter which makes use of 6 SCRs or thyristors, will have the gating pulse received for each SCR at an interval of 60 degree. And sometimes what happens, this gating signal obtained from firing circuit might not be having enough strength or enough magnitude to turn on the SCR or the power device. So the signal is first fed to a driver circuit which may consist of a pulse amplifier, and then it is applied to gate cathode circuit. Now we have the R triggering method. So R triggering method, here we see there is R1, R2 and resistor R with a diode also connected in parallel with the thyristor, that is the main power device here, and this is the load which has to be supplied from the AC. So R1 is the current limiting resistor, R2 is the variable resistance. When R2 is made 0, R1 is acting as a current limiting resistor and will avoid the damage of the SCR due to high current in absence of R2 value. And down here we have the resistor R. This is the stabilizing resistance. Voltage across it is used as a gating voltage across gate cathode, that will forward bias it. And the function of diode is to allow only the current to flow during the positive half cycle. During negative half cycle, it will have a peak inverse voltage rating that is greater than the maximum voltage applied in the negative half. So as the voltage is increasing for the positive half cycle, B point is positive with respect to down here cathode, but the SCR is not turned on because the gating current, minimum gating current has not reached. Simultaneously, the voltage positive for the half cycle, diode is also forward biased, and there is a limited current flowing through the resistor R1, R2 and diode to the gate of the SCR, which will reach a minimum current and then it will turn on the SCR, and thereafter we'll have the load current flowing through the load through the device back to the negative supply. So we will have the output voltage obtained across load and power delivered to the load. During the negative half cycle, this whole negative uh, supply will appear across the SCR. During on state, it will behave as closed circuit SCR and with a voltage drop of 1 to 2 volt, and this external current will be limited by the load impedance. The firing angle can be calculated by using this formula sine inverse VGT into the sum of three resistors R1 plus R2 plus R divided by Vm by R. So here all these terms are constant, only R2 is variable. So that means alpha is firing angle is dependent upon R2. We can control using R2 firing angle. So it is the simplest and most economical method, but it suffers from a limited range of firing angle here, that can be from 0 to 90 degree. Moreover, it is temperature dependent to reach the IG mean. So here we have the three waveforms corresponding to firing angle 0, then firing angle equal to 90 degree, and firing angle alpha equal less than 90 degree. So when there is no firing, whole voltage positive half cycle and negative half cycle appears across the thyristor Vt here. Second case where it is in the forward blocking mode, voltage across the SCR develops till the firing getting current reaches the VGT mean or IG mean, and moment it is turned on, say here it is at 90 degree, the load voltage is obtained across the load as IG current is flowing, and voltage across the device is of the order 1 to 2 volt in the on state, and whole negative half cycle is appearing across the SCR. When the firing angle is reduced, more load voltage is obtained, more power is obtained. So that power could be ranging from 100 to 50% with the firing angle 0 to 90 degree. Now second method, RC triggering method. In order to obtain firing angle greater than 90 degree, that is 0 to 180 degree, we need RC trigger circuit. This circuit can be either a half wave trigger circuit or full wave trigger circuit. So here we have the half wave trigger circuit first. So in this During the negative half cycle, the capacitor is charged with the lower plate positive and upper plate negative to maximum voltage Vm of the supply voltage, and this charging is through the diode D2, as it offers lesser resistance as compared to the resistor here. So this is the charging path during negative half cycle, and as the negative supply goes on decreasing towards 0, the capacitor voltage also try to decrease, and as it is moving from supply voltage moving from 0 to positive side for the positive half cycle, the capacitor voltage is decreasing. Now this end is positive and this end is negative, so as the voltage across here, first it will decrease to 0 voltage across capacitor, and then it will charge with the upper plate positive and lower plate negative, and when this voltage is equal to Vd1 plus Vg min, the minimum getting voltage required, plus voltage drop across diode, say 0.7 volt, then the SCR is turned on and main load current will flow through this path, the SCR. So the here RC required is greater than or equal to 1.3 T by 2, that is equal to 4 by omega, where T is the time period of the AC cycle, and SCR will turn on when Vc is equal to Vg min plus Vd1 that we discussed, and Ig min is available through resistor R diode D1 and gate to cathode circuit of SCR, and this is the resistor value should be less than or equal to Vs minus a Vg min minus Vd1 by Ig min, where Vs is the instantaneous value at which SCR turns on, and at lower voltage across SCR, that is 1 to 1.5 volt, during the conduction keeps the capacitor discharged during positive half cycle, and during negative half cycle voltage charges C to minus Vm, and for low value of resistance alpha is less than 90 degree, therefore average output is large, and for large value of resistance alpha will be greater than 90 degree, and therefore average output is low. Now here we have the second waveform, that is RC full wave trigger circuit, which makes use of 4 diodes D1, D2, D3 and D4. It is forming a bridge rectifier, full wave bridge rectifier. So this rectifier or the bridge diodes will conduct for both positive half cycle and negative half cycle, and thus providing getting voltage to the SCR for positive as well as negative half, and thus doubling the power available to the load. In case of single half wave rectifier trigger circuit, we had only the load voltage for the positive half cycle, no output for the negative half cycle, but here we are getting the output for the positive as well as for negative half cycle, and this is the RC component used as the primary component, where R is variable. So when this R is more, that means it will take more time for the capacitor to develop the minimum getting voltage, and turning on of the SCR is delayed. So more the time capacitor takes to charge to the minimum getting voltage, lesser the output voltage available to the load. So this is the graph shown here. RC value here should be greater than or equal to 50 T by 2, that is approximately 157 by omega, and the resistor value can be calculated as less than or equal to Vs minus Vg min by Ig min. So here Vs is the source voltage at which SCR turns on, and alpha varies from 0 to 180 degree. So here we have the comparison of the two methods, R triggering and RC triggering. Firing angle can be varied from 0 to 90 degree in R triggering, whereas for RC triggering 0 to 180 degree. Cost less costly R triggering, RC is more, and power control is 100% to 50%, whereas here can be controlled from 0 to 100% in RC. So These are the references, and thank you very much.